This lecture will cover multi-species occupancy models. I will begin with the motivation for co-occurrence models, present the parameters and species interaction factors, and finish with the conditional parameterization. The biological question is, do some species co-occur more or less often than expected? This question is the basis for hypotheses about mutualism and competition in community ecology. A great deal of literature has been published during the past 30 years on methods for assessing patterns of co-occurrence. However, these do not usually account for incomplete detection. Let's take a look at a species co-occurrence matrix where sites are the rows and species are the columns. The problem with the historical approaches is that they assume the zeros are true absence of the species. However, we know the detection of animals in surveys is usually imperfect. Just as in the other occupancy models, repeat surveys of the sites allow us to estimate detection probabilities for the species. If detection is not dependent on the presence of other species, then the sign of the species interaction may be correct, but the magnitude of the interaction will be underestimated. However, if detection is dependent on the presence of other species, then the species interaction may be completely misleading. Now let's take a look at a Venn diagram for the co-occurrence of species A and B. The ovals represent the set of sampling units occupied by each species. The intersection represents the sites occupied by both species. This region corresponds to sites occupied by only species A and can be estimated by the occupancy of species A minus the occupancy of both species. This region represents sites occupied by only species B and can be estimated by the occupancy of species B minus the occupancy of both species. The probability a site is unoccupied can be estimated by 1 minus the occupancy rates for species A and B plus the occupancy rate for both species. Here, phi is a vector of possible states for the two-species model where the elements sum to 1. The species occupancy parameters for the two-species model are psi A, the probability a site is occupied by species A, psi B, the probability the site is occupied by species B, and psi AB, the probability the site is occupied by species A and B. Now let's go over the detection parameters. PL is the detection for species L given only species L is present. R, capital A, capital B, is the probability of detecting species A and B. R, capital A, lowercase b, is the probability of detecting species A but not B. R, lowercase a, capital B, is the probability of detecting species B but not A. And R, lowercase a and b, is the probability of detecting neither species. Let's consider the following encounter history with two repeat surveys for species A and B. Here we have to account for two possibilities. Either both species are present with probability psi AB, but only species A was detected on survey 1 and 2 with probability R. Or only species A was present with probability psi A minus psi AB and was detected on survey 1 and 2 with probability PA. Building a two-species model proceeds by defining vectors for the occupancy and detection states. Phi naught is the vector of possible states for the occupancy of species A and B prior to surveying at time 0. The detection states for the encounter history are the same as in the previous slide. For occupancy state AB, here are the probabilities of detecting species A and not B on survey 1 and 2. For the occupancy of species A only, here are the probabilities of detecting species A when only species A is present on survey 1 and 2. For this encounter history, it is not possible to have occupancy of species B only, so detection is 0 for this state. Likewise, it is not possible for the site to be unoccupied, so P is 0. Now let's consider a reparameterization that allows direct inference on the interaction between two species. If species occur independently, the joint occupancy of both species should equal the product of the occupancy probabilities for each species. Here, the extent that species co-occur is quantified by little phi, or the ratio of how likely the species are to co-occur compared to what is expected if they occurred independently. The reparameterization directly models phi as a species interaction factor, where the species occur independently if phi is 1. The model can also accommodate a species interaction factor for detection, where the detections are independent if delta equals 1. We can determine if the detection of one species affects the detection of another. For example, the model constraint with the detection of species A only equal to the detection of species A when species B is present can be compared to a model with separate parameter estimates. The constraints for the detection of species B can be done in the same way. Covariates for vegetation or weather on psi R and P can be incorporated in the usual way using the logit link. The log-link function can be used for the species interaction factors on occupancy and detection. However, the log-link may not behave well for some parameter values. Now let's go over a parameterization that estimates the occupancy of a subordinate species conditional on the presence of a dominant species. This model overcomes the convergence problems when covariates are used with the log-link to model the species interaction factors. The first level of the hierarchy represents the presence-absence of the dominant species. The second level represents the presence-absence of the subordinate species, conditional on the presence of the dominant species. And the lower branches represent the conditional detection probabilities for the species. Using the model constraints below, we can ask, does the occupancy of subordinate species depend on the presence of the dominant species? The question, does detection of either species depend on the presence of the other? This can be answered using models with these constraints. We can also ask, does detection of the subordinate species depend on the detection of the dominant species using the following constraints?